Hi folks, it's Mike at Airnetics. In this video we're going to walk through the details of the master map screen and each of the other screens one at a time. So we'll start with the master map, and we've got in the middle a gray topology map of what your network looks like with the local fixed master or mobile master. Any of the master varieties would show at the bottom. So this computer is connected via USB cable to this device at the bottom. If you want to rename that, you can open his monitor window and give him a name, and I'll change it to Master 1 just to show you how this works. We're going to register the node. It says it's updated. Then we'll close this back down, and now we've got Master 1. Same thing can happen with each of the remotes. Just to show an example, register that node. It's been updated. So now 2A. So these are your remotes. This is the master. You double click on a remote to bring up his relay monitor window, or you can highlight the ramp and click on open relay monitor window here. So those two ways. These can be moved around. There is an auto layout function that keeps them fixed if you want to use that, etc., etc. So this is again a representation of all of the remotes. Now as you get a repeated node in the mix here, you'll see one connected through the other one, and we'll do that later. But just to go through the screen, the top left is the master transmit receive selection, so we can have the transmitters either in auto or manual mode. Keep the master in manual. That is the best way to do this. We don't need an auto for the master. And these are the transmit channel 1 and channel 2 channel selection up and down arrows. Just leave this in 1 and 6. The standard channel allocations start with 1 and 6, go to 2 and 7 for the next hop, 3 and 8, and so forth, all the way up to 5 and 10. There are 5 channel pairs available, and this is how we set those. So this should always be left in 1 and 6 for the master. Transmit diversity is a way of using only one of the 2 transmit channels, but you'll find that you really need transmit diversity in most links, so leave that on. And what that means is that the master will transmit a burst on channel 1, and then it transmits a second burst on channel 2. Both of the bursts contain the same information, so we have diversity, both in space and time, so that the signal is more reliable down the network. The uplink control channel, this is the reverse channel. You'll see a 1 and a 6 here on this particular link. The 1 is the outbound channel, so we use the same channel for the return channel for our two-way data control of each remote. So the UCC or uplink control channel is shown here. It's not something you need to do anything with. It's just an indication of what is being used. Transmit power, this is plus 20 dBm. Always leave it on 20. You can move it down a little bit, but you really want to keep this at max power at all times. So leave that on plus 20. So down below is the master audio. This is the audio coming into the audio input of the master transmitter, and you have a left and a right channel with a volume control. Again, typically just leave this at 0 and don't pump up the gain any on the fixed master. Now you'll notice if you're using a mobile master, the mobile master tends to use about a plus 10 dBm gain or plus 10 dB gain for audio, just to overcome the noise in the system and to provide enough gain for a microphone that's connected to it. So on a mobile master, leave this guy at about 10, but on a fixed master, leave it at about 0. And whatever your source is coming in, for example, cloud cover on a web streaming app, you can use the volume control on that app instead of this to get more gain if it's needed. This is an audio mute at the input of the fixed master, so it mutes anything coming in to the fixed master. When the master is muted, you'll see this red light blinking, and this is a way just to manually mute the entire network. So that's the audio section of the fixed master. Alarms we'll go through in more detail later, but when there's an alarm pending, you'll have a time on the bottom here showing how many seconds left until the alarm gets sent, and the light will be flashing. So we'll go through the alarms a little later. This is an indication of which node you're monitoring. We've talked about opening the monitor window. So this is called auto mute, and auto mute, if it's on, the fixed master will automatically mute its input if it's not being talked to by the network management system. So keep that in mind if you are, for example, planning to use your mobile master outside without a laptop. You want to click this to off so that the network management system is not required to be talking to this master for it to play music. So it is a fail-safe. For example, if it's on and at night something happens to the scheduler or the laptop, it will self-mute if it's in this mode. So again, with the fixed master connected to prevent accidental music at midnight, you want to leave this on. Polling list and so forth is for debugging, and we won't need that at this point. So that's the master map. Let me go over here to the RSSI. So whichever unit you're monitoring, whichever unit is highlighted, will show up in this window. It shows the receive signal strength indicator of each of the two antennas on that remote unit. So red is right and yellow is left. So that will show you which antenna's got the bigger signal. Typically, on some units, we'll disable one of the antennas if the signal is very low, and I'll go through that on the relay monitor window. This is missed polls, so we send out a poll to each remote independently, and if we don't get a response, we say we've missed a poll. So having an occasional missed poll is just an element of the system timing. It's not a big deal, it doesn't hurt anything. But if you miss a lot of polls, you'll see this ramp up to 100% missed polls. Once you've missed 10 polls in a row, the unit will go offline and try to reacquire, and the network management system will consider it offline. So it will have to go back through the reacquisition process. But if you're getting a lot of missed polls, it's probably interference. And if you're getting dropped packets, then we need to do something about that interference. But again, occasional missed polls, no big deal. The bottom graph is called packet error rate, and again we send out two packets, one on channel 1 and one on channel 6. If you get the first packet, if it's properly received at a remote, you will get no drop packets shown here. If you miss the first packet and you receive the second packet successfully, you'll get a green blip showing that you had to use the second or redundant packet to receive the information. And that happens occasionally if a car goes by and you get ignition noise, or if there's ongoing interference and you can always get the second but not the first, you'll see this green bar bouncing around continuously at some percentage. So again, if you get no drop packet on the first one, you get no blips of any kind. If you miss the first one, get the second one, you get a green blip. If you miss both packets, you will get a red blip, and that means you have a dropout. Now with the newest software, dropouts don't matter nearly as much as they used to. We have what's called packet loss concealment. So if you miss an occasional packet, you probably will not hear that. It's covered up essentially by packet loss concealment technique. So occasional dropouts are okay now. Consistent high levels of dropout you will hear, and you need to mitigate the interference in some way. So that's a fairly detailed overview of the master map screen, and we'll go to another video to go through the other screens.